everyone, it's Alyssa and welcome to You Can Learn Math. Right, so this is a continuation talking about long division in a little more complicated way. Not that the way I'm talking about it will be complicated, but the problems look more complicated. But as you'll discover today, it's actually not. Yay! Okay, so same process that we used before. As an example, I'm just going to pick some sort of random number here, and we'll say like 253. Okay, for this process, what we did is we took the entire first number out here, the entire divisor out here. We say, does it go into the first one? 2. No, it doesn't. Then we add another. Does it go into 25? Yes, it does. It goes 6 times. 6 times 4 is 24. We subtract, we get 1. Bring down the 3. Does 4 go into 13? Yes, it does. 3 times. 3 times 4 is 12. Subtract, get 1, remainder 1. I'm going through this very quickly. Just as a quick reminder, the entire video, which takes us a little more slowly, a little more step by step, link is in the description below. Okay, but just as a reminder that this is the process when we're doing division with this single number out here. Okay, so we're going to move on today and do what if we have a bigger number? What if we had 12, a 2-digit number on the outside? Now I'm going to do this with something that you may know from the 12 times tables. You may go, oh, well, I know 12 times 12 is 144, which is great, but we're going to do it as if we didn't know that just to show the process. Okay, so first thing, 12 into, because remember, whole thing, whole number that's out here, 12, the whole number 12, does it go into 1? No, it doesn't. Does it go into 14? Yes, it does. How many times? 1 time. Sorry, it's a little polleny. We go back, 1 times 12, and then we write it down here. That is 12. We subtract, we get 2. Does 12 go into 2? No, it doesn't, which is good. We don't want it to go into 2. Then we bring down the next number, which is 4. Does 12 go into 24? Yes, it does. It goes 2 times. 2 times 12 is 24. We subtract, we get 0, remainder of 0. So as you see, it's the same process as the division we did in that previous video. It's the same process. It just looks a little more complicated, and we have these 2-digit numbers instead of just the single-digit numbers. Okay, so here's one I want to show you, and I'm going to show you with a what if I did something like this? Okay, there's a principle I'd like to show you before we move on. Okay, if I said, all right, my whole thing here, 12. If I said, does 12 go into 2? You say no. Does 12 go into 24? Yes, it goes 2 times. 2 times 12 is 24. Subtract, we get 0. Does 12 go into 0? No. So we bring down the next number, 0. Does 12 go into 0? No. So what do you do next? You might go, oh, well, I'll just bring down the next 0. Not so fast. Once we bring down a number, we have to write something above it. At that point, we have to. So I've brought that 0 down, and then does 12 go into 0? No, I have to write a 0 above it. It goes 0 times. And we can even multiply it back. 0 times 12 is 0. Subtract that 0. Does 12 go into 0? No. Bring down a 0. I've brought something down, so I have to write something at the top. Does 12 go into 0? No. Should have wrote it in red to be consistent. There we go. 0 times 12 is 0. Subtract, and we get 0, so it's a remainder of 0. So I know this is a more simplistic way of showing that, but this will happen with other things. Let's say if it ended up being something that's very similar, but what if it was just, get rid of all these excess sort of things. What if it was like this? And we said, okay, does 12 go into 0? No. Bring down the 1. Does 12 go into 1? No, it doesn't. So I have to write a 0 above it. I brought something down. I have to write a number above it. Play back. 0. Bring down the next 0. 12, does it go into 10? No, I have to write something there. Zoom out. 0 times 12 is 0, and I have a remainder of 10. But anytime I bring down a number, I have to write a number above it. That's why up here, this very first stage, that's why I'm zooming in. Okay, at this very first stage, when I'm saying, does this whole number 12, does it go into 2? No. Does it go into 24? Yes. And then I write that number directly above the last place of the number that I'm going into, because I'm going into 24 at that point. So I write the 2 directly above that last place. The reason that's so important and why I don't just write it wherever I want, like, oh, I'll just write it here, I'll write it over here. By writing it there, I've ensured I have to have a number up here in my answer above each number in the number that's being divided. There has to be, once I've started, have to have a number above each one. Okay, so those are just some general pointers there for that scenario, which does come up. All right, so what if I had something like, say, I am picking random numbers, so who knows how this is going to turn out. Okay, 54 into 673. Same process, even though we have a bigger number. I use the whole number 54 and say, does it go into 6? No. Does it go into 67? Yes. So I go directly above the 7 and I write 54 goes into 67 one time. Multiply back. 1 times 54 is 54. I subtract 13. Does 54 go into 13? No. Let me bring down my 3. Does 54 go into 133? Yes. Now, what some people or some students ask me is, well, how do I know when I'm getting these numbers that I don't know these times tables, and my teacher doesn't want me to use a calculator because the point of this is not to use a calculator, but for me to do it. So how do I know how many times 54 goes into 133? Well, this is the educated guess part. 54, we can do estimating in our head. 54 rounds down to 50. 133 rounds to 130. How many times does 50 go into 130? 50 into 130. And because they both end in 0, we can say, how many times does 5 go into 13? 2, right? 5 times 2 is 10. 3 is too much. 5 times 3 is 15. So let's try, and it doesn't want me to erase. Let's try 2. Now this doesn't always, actually just back it up. It doesn't always work, and it's okay if it doesn't work. You just move up or down accordingly. So this time we're going to say, all right, 2. 2 times 54. Now the way that you can write this off to the side, you can write 54 times 2, or you can do it like this. You kind of in your head, you're going 2 times 4 is 8. Then 2 times 5 is 10. Then I subtract those and I get 25. Does 54 go into 25? Nope. And no more numbers to bring down. 12, remainder of 25. Again, if you want to multiply it off to the side like that, it's fine. No big deal. Just do that. Okay. What if it's an even bigger number? I'm just picking random things here. 165 into, oh, let's get crazy. 56,119. I don't know. Okay. 165 into 56,119. You're like, why are you doing this to me? Why are you doing this to me, Alyssa? This is crazy. It's the same process. We do the same thing. We take the whole number out here. We do not break it up. 165. Does that go into 5? No. Does it go into 56? No. Does it go into 561? Yes. How many times? Well, this one might be a little tricky. We go 165 into 561. Well, if I think of 16 and 56, 16 times 2 is 32. If I add 16 more to that to be 16 times 3, I get 48. So maybe 3. We don't always know. Sometimes it can be very close and you're like, and then when you multiply, you find you've gone over, but you can never go over. In that case, all you would do is just go down a number. Like say if I guessed 16 times 4 and I tried that and it was too high, just go down back to 3. It's not a big deal. It's okay. All right, so I'm going to try 3. Okay, so I'm going to do this both ways. If I multiply it off here to the side, 165 times 3. 3 times 5 is 15. Carry the 1. 6 times 3 is 18. Plus 1 is 19. 9. Carry the 1. 3 times 1 is 3. Plus 1 is 4. Okay? Now here's how I would do it if I was doing this in my head. I'd go 3 times 5 is, I'm going to use red to show, is 15. Write down my 5. Carry my 1. 3 times 6 is 18. Plus that 1 is 19. Write down my 9. Carry my 1. 3 times 1 is 3. Plus 1 is 4. Now for some people with the little ones over on the side, that can get confusing. I totally understand that, in which case just write it over to the left. Okay, so I'm going to subtract these. 1 minus 5, I can't do that, so I borrow from here. That becomes 11 minus 5 is 6. 5 minus 9, can't do it. I borrow from here. 15 minus 9 is 6. Does 165 go into 66? No. So I bring down a 1. Does 165 go into 661? Yes. Now there we have 495, so I'm going to guess this is going to be times 4. We'll see. We'll see if that works. Times 4. And again, if you need to write this over to the side, it's fine, but for now, I'm just going to kind of multiply it inside. 4 times 5 is 20. Put down my 0, carry my 2. 4 times 6 is 24, plus 2 is 26. Put down my 6, carry my 2. 4 times 1 is 4, plus 2 is 6. Wow, that worked out perfectly. 661 minus 660 is 1. 165 does not go into 1. So I bring down my last number 9. Does it go into 19? No, it doesn't. But I don't just go, oh, well, there's nothing else to bring down. I can't do anything. I brought a number down, so I have to write a number above it. Has to be a number above every one. So does 165 go into 19? No. I write a 0. And we can multiply it back. 0 times 165 is 0. Leaves us with a remainder of 19. All right. So that's it for long division. Did a couple of examples there. If you have any questions, leave them in the comments below. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.